Okay, I have a quick one for you. I want to go back for a second to Pascal's triangle and fill in the numbers in Pascal's triangle in this little triangle honeycomb thing that I've written up here. So let's do that. So I'm going to start by putting a 1 here, and then remember with Pascal's triangle, 1 and 1, it always starts with a 1, then you add these two to get this one. So 1 and 1 is 2. Fill that in. That's going to be a 1. That will be a 1 there, and then 1 and 2 is 3. 2 and 1 is 3, and then I end with a 1. So now I have 1, 4, 7, 21, 35, 35, 21, 7, and 1. Now, the next thing I want to do is I want to go over to what the numbers that I've drawn in right here, the numbers I put in right here, and I want to color in all the odd numbers. So I'm going to color in all the 1s. I'm going to color in all the odd numbers. So we're really back to that very first sequence that we did in the very first video on sequences. So that's an odd number 1. I'll color that in. 2's even, so I won't. 1's odd, so I'll color that in. Okay. And then here I have a 1. Color that in. 3, that's an odd number. I'll color that in. Another 3, color that in. 1. So all I'm doing is finding all the odd numbers in Pascal's triangle and just shading them in, shading in the little geometric thing I have there. Okay, so there I've got all the odd numbers in Pascal's triangle colored in. Okay, so what you see there when I do this, when I take and step back a little bit and look at what happens when I color in all the odd numbers in Pascal's triangle, it looks as though I'm getting the Sierpinski triangle. It starts to resemble that Sierpinski triangle. Now, if I continue on down more and more rows like this, it will start to look more and more like the Sierpinski triangle. In fact, the Sierpinski triangle will just fall right out of Pascal's triangle by taking Pascal's triangle and coloring in all the odd numbers. Let me show you what that looks like. So here's what we have with the triangle extended a little bit. Now this is what it looks like if I continue to color in the odd numbers. See, it looks more and more like the Sierpinski triangle. And finally, here's what it looks like if I go down in many, many rows and color in all the odd numbers. So pretty interesting, I think, that the Sierpinski triangle comes right out of Pascal's triangle simply by coloring in all the odd numbers. So again, this is one of the things that drew me to mathematics in the first place, when I would see things that initially looked to be unrelated and then find out that there's actually a very nice relationship between them. And who would expect that Pascal's triangle and the Sierpinski triangle would be related in the way that they are? But they are.